This is section 2.6 of Algebra 1, and this is all about percent problems. Now, I want to put a qualifier out there. It's likely that you may have learned how to do these problems a little bit of a different way back in middle school, and that's not wrong. It's fine to do it that way, but the reason I'm showing you kind of a new way is because we're going to be talking about writing equations, and we're going to develop this concept of application problems, and you have to get good at writing equations. And so I think this method that I'm going to show you, it's much more commonly used as you go forward in your math education. And so this is the one that's going to really serve you better. So please try and follow the method that I'm using, okay? So first of all, in order to solve percent problems, we've got 3 steps. Number 1, translate words into equations, okay? It's all about equations. Okay, translate words into equations by replacing the what phrase with a variable. Okay, by replacing the, like if it says what number, what percent, what total. So when you see the word what, that's going to be your x or your whatever variable you're using. And a little hint, remember percent numbers are written as decimals. Okay, so when I read number 1, I'm going to replace all the different phrases with math. So when it says what number, there's the what phrase, what number, so that's going to be my x. Remember how we talked about the word is? Okay, the word is means equals. And then it says 29%. And so remember how we said we write percents as decimals, right? So in place of 29%, let's write 0.29. So in place of 29%, we're going to write 0.29. And then you may or may not remember when we were interpreting all the different words and math symbols, the word of means we're going to multiply. And then what are we going to multiply that by? 350. So I'm going to multiply 0.29 times 350. And I wanted to use the dot to show you that of means multiply, but I probably wouldn't write it like this, right? I would probably imply multiplication by using a parentheses. Okay, so step 2 is solve the equation. Well, in this case, the x is already by itself. So if I want to know what x is, I'll just put in my calculator 0.29 times 350. And I get 101.5. So x equals 101.5. And then it says, interpret your results. See if your answer makes sense in the problem. So in other words, when they say what number, I'm saying the number 101. So is it possible that around 101 is 29% of 350? Well, sure it is. I mean, I'm not saying I can tell exactly that it's 29%, but I know that 101 is like 100 is about a third of 300, right? And a third would be, around 29%. I guess a third would be like 33%. I'm just, thinking big picture and estimating, does it make sense that this could be approximately the right number? And I think it does. Okay, so number 2, let's translate into an equation. So it says the number 78. Notice there's no what phrase. It just says the number 78. So 78, what do I put in place of the word is? Equals. And then it says what percent. Okay, there's the what phrase. So that's going to be my x. What percent of means multiply, of 150. So times 150. Okay, 78 is what percent of 150? All right, well, there's my equation. If I want to solve for x, how do I get rid of that 150? Whoops. Isn't that 150 actually being multiplied by, just scooching this up over here, isn't that 150 being multiplied by x? So if I want to get rid of the 150, wouldn't I divide both sides by 150? Okay, so they cancel out. So x equals whatever 78 divided by 150 is. So put it in your calculator, 78 divided by 150. And notice we get 0.52, right? So I came up with x equals 0.52. Now let's see if this makes sense. The number 78 is what percent? Okay, so x, my what, is a percent. So instead of saying 0.52, we're going to say what percent? We're going to say 52%. Okay, so does that make sense? Could it be that 78 is about 52% of 150? Well, that seems reasonable. I mean, it seems about half of 150. Not exactly, but it seems about half of 150. So it's a reasonable answer. Okay, look at number 3. The number 23, there's no what phrase yet, so 23 means equals. In place of 60%, we're going to put 0.60 or just 0.6, same thing. And then it says of, so times what number? So times x. In this case, I didn't really have to put the x in parentheses, right? But that's fine. It's being multiplied. Since it's being multiplied, if I want to solve for x, wouldn't I divide both sides by 0.60? Divide both sides by 0.60. So 23 divided by 0.60 is going to be 38.33333. Whoa. So I'm going to say my answer is 38 point, and I'll just do this, right? Instead of saying 333, because that means 3 repeating. Okay, so does that make sense? The number 23 is 60% of what number? So do you think 60% of about 38 is 23? Well, yeah, I mean, it's over half, right? So that makes sense. Okay. Next type. Okay, so let's do one more type of problem. This is called percent of change. I don't really think that we need this box right here. So we'll ignore that part. Let's go down to right here where it says percent of change. Okay. So our formula for percent of change is amount of change all over, and notice this is like a big giant fraction line right here. It's the amount of change all over the total amount. Amount of change over the total amount. So for example, what is the percent of increase? So that's the same as saying the percent of change. Okay, so I want to find the percent of change if a particular item went from $59 to $63.95. So in order to find the percent of increase, same as saying percent of change, I'm going to take the amount of change. Well, if it started at 59 and it went up to 63.95, what's the amount that it increased? Well, wouldn't I just subtract? So let's use our calculator. What is 63.95 minus 59? So it went up by 4.95. So the amount of change was 4.95. And then we want to divide by the total amount. Well, what's the total amount? Well, that means we should say here the total beginning amount. Okay, the total beginning amount. So in this case, what was the beginning amount? Well, it went from $59. So that means it started at $59. So the percent of increase is whatever we get when we divide these two numbers. So on my calculator, let's do 4.95 divided by 59, and we get the decimal 0.08, if we round it, 0.084. So that comes out to equal 0.084. Okay, well, we're finding a percent, right? Since this represents the percent of increase, let's actually write it as a percent. So as a percent, wouldn't we move that over 2 places? So that would be 8.4% of increase. Okay, look at the next page. Let's first of all do, I'm trying to think here. We're not going to do number 2 at all. I have that like on another homework that we'll look at. Let's look at number 3. Okay, if I want to do number 3. I noticed on Monday the gas price at my favorite gas station, was $2.09 per gallon. You can tell I wrote this problem a long time ago because you can't get gas for $2.09. Okay, it was $2.09 per gallon. But on Saturday, the price was $2.29. Okay, so what was the percent of increase? All right, there's my phrase. If I want to find the percent of increase, okay, I need to take the amount of change. Well, if it went from 209 to 229, doesn't that mean it went up by 20 cents? So the amount of change is 20 cents over the total beginning amount. Well, which one of those was the beginning amount? Well, it was 209, right? So divided by 209. So use your calculator. What does that come out to be? 0.2 divided by 209. And if we round it to 3, that's going to be 0.096. So 0.096. But since this represents a percent, we would write it as 9.6%. Okay. So let's go back to number 1. So even though this isn't a percent of increase necessarily, I do want to just kind of remind you that what we said for percent problems, sometimes it's helpful to write an equation. Okay, it always comes down to equations. All right, Susie Shopper wants to purchase a new dress that is on sale for 30% off. Okay, if the sale price is $75, what was the original price? Okay, so let's think about this. I'll call my original price the X because that's what I'm trying to find, right? So if the original price is my X, so think about it this way. Here's how I think the easiest way to think about this. It's not the only way, but I think it's the easiest. If it's on sale for 30% off, right? If they're taking off 30%, then what percent am I actually paying? Well, if I'm getting 30% subtracted off, doesn't that mean I'm actually paying the other 70%? So what I'm trying to figure out is, let me back this up. What is 70% of, let me rephrase, sorry about that. I want to know 70% of what number, because that's my original cost. 70% of what number is $75. Okay, 70% of what number is $75. So let's write that as an equation. 70% of means times what number is my X is $75. So if I want to solve for X, wouldn't I just divide both sides by 0.7? So X equals 75 divided by 0.7. If you put that in your calculator, 75 divided by 0.7 comes out to be 107.14. 107.14. So what was the original price? We're saying that the original price was $107.14. So does that make sense? If I get a 30% off sale, that maybe I'm going to buy it for $75. That seems like appropriate. All right, so let's leave it at that.